Hello everyone, today we are going to perform simulation on driven cavity flow problem. So this is a square in which we have air and the top wall is moving with 1 meter per second and density is 100 kg per meter cube and this is viscosity. So first let's go to ANSYS workbench, choose fluid flow. Before going to geometry, select on property, set this analysis type from 3D to 2D. Now take design modeler, take XY plane, look at sketching, take rectangle, dimension 1 meter, 1 meter. Modeling, concept, line from sketches. Concept, surface from sketch. Take sketch, generate. Now we have our square. Okay, so now close the geometry, go to meshing, surface body. Okay, now go to mesh, give sizing, say duplicate, or you can just give one sizing. Select all the edges, apply, set type to number of divisions, let's see about 100. Okay, now add face meshing for a regular mesh. Now generate mesh, okay, let's increase to 150 and see. Okay, now come to name selection, take edge filter, select this top edge, give it name as moving ball, moving ball. Okay, update, Fluent mesh successful, close, go to setup. As this simple problem, you can just go with the default without taking double precision and all those things. Okay, we're going to do steady state 2D planar. Okay, now let's go to viscous, which is set to laminar, and it is a laminar because in the problem statement the Reynolds number is 100. If we are using 100 as a density and 1 as a viscosity, then Reynolds numbers becomes 100, which is a laminar flow. So laminar flow, so go to material, set air, density 100, viscosity 1, change close. Now go to change cell zone condition, surface body set to fluid. Okay, now move to boundary condition, set this moving wall, edit, set to moving wall, speed 1 meter per second, and the direction is X, that is this one. Okay, now that's it. We'll set the residual to default values. Now look at method, it's supposed to simple. Okay, simple, change this momentum to first order up point, go to initialization, set standard initialization and initialize. Now come to run calculation, set it 2000 iterations, reporting interval I'm setting as 10, and as well as this profile update interval as well as 10. So click on calculate. Solution is completed. Now close this ANSYS Fluent, come to results. Let's have a look at vector. Set symmetry 1. This symmetry 1 and symmetry 2 are this perpendicular face about positive z, and the other symmetry 2 is opposite to the symmetric one. So symmetry 1 is perpendicular to the z axis and symmetry 2 is perpendicular to negative z axis. So if you select that, you will get your vectors. Even if you select symmetry 2, you will also get the same results. You will get the same results. Nothing is changing there. Set it to 5. Now you will see cavity, the flow, velocity vector. If you even increase this number, you will get less and less vector points. Then you can take this symbol and increase the vector for more visualization. We can also draw this streamline symmetry 1, let's say 50. Okay, 25. And this is surface streamline. If I say 25, you get the idea by looking at the picture. You can also animate using the streamline. Go to option, ball, change this ball diameter, so you can see that. Let me just decrease this a bit. That's a 10. Okay, now apply the streamline. In this direction. So okay, stop the video. Pause, simply pause. You can also take counter, disable this streamline, apply, change it to velocity, change this to 50,